Hello everyone. In this video we'll be taking a look at the Phillips Videopac G7000, also known across the pond as the Magnavox Odyssey 2. This second generation video game console was released in 1978. I bought the G7000 on eBay for £6.18. The condition of the console is not great, with dirt and grime all around the system, and even present on the keyboard. There is a slight crack on the side of the console, and the cartridge port has seen better days. Finally, let's not forget about the console's video RF output cable, which has now formed rust, and the console really needs a modern video output upgrade. So, without further ado, let's begin the restoration. So we have the G7000 on the blue mat, so let's give the console a simple clean using an antibacterial wipe. Cleaning all the accessible areas around the console. Cleaning the front, the sides, and the back of the console. Clean off all that old grime that's built up over the years. And let's not forget to also clean the bottom of the console too, which is also dirty too. And while not perfect, it is a lot cleaner than it was before. So after giving the Videopac G7000 a clean with an antibacterial wipe, I'm a lot more confident now to hold this system now. Before it was very dirty, it was very dirty and grimy it was, and you saw it when basically we cleaned it. There was just a lot of dirt that was just being removed from the system. And remember, this system is over 40 years old, so we don't know exactly what's been on this system, but I'm more confident now to actually hold the system now and proceed with the next part, because although we've cleaned basically the surface of the system, there's still a lot of dirt and grime inside these sections here. On the plastic itself, there's a lot of dirt and grime that's basically clogged to the plastic. A lot of dirt on the cartridge port, and I guarantee inside it's very dirty and it's very dirty, dusty. It's just collected over 40 years. So what we now need to do is we now need to tear down the system and proceed with taking each part and giving it a well-deserved clean in soap and water, and that's going to be the best way of basically restoring this system and giving it a really well-deserved clean. So let's now turn over the console, where we are presented with 3 bolts. To remove the 3 bolts around the G7000, we have to use an hex-bit screwdriver. One by one we remove the bolts. 2 of the bolts I was able to remove. The third unfortunately seems like the screw post inside the console has broken, causing it to consistently turn. We're now able to freely remove the bottom shell from the G7000. This is where we are presented for the first time with the main board and the RF modulator. First we need to remove the main board. There are 4 bolts holding it down. We then remove the RF connector away from the main board. There is a metal strap which is soldered to the main board and the RF modulator. Once removed, we can slowly lift up the main board. Not completely, as there is a ribbon cable attached which we need to disconnect away from the main board. So let's put the shell to one side for now and let's focus on the main board. As you can see, the board is very dirty. Also, the RF shield is very dirty with lots of corrosion around it. So the RF shield is held together with clips which need to be turned. Turning them will release the top part of the shield. And this will give us our first look at the hardware that powers the G7000. There are 3 additional shields that we need to remove. One is under the board. We need to free it by desoldering it away from the board. This will then give us access to then desolder the other 2 shields. And with the 2 shields now desoldered and removed, we now need to remove the surrounding shield by desoldering it. And with the surrounding shield now removed, we now have access to the whole board. Let's now talk about the hardware that powers the Phillips Videopac computer G7000. The G7000 is powered by the 8-bit Intel 8048 microcontroller MCU, released in 1976. It was Intel's first ever microcontroller, clocked at 1.79 MHz. The 8048 has 64 bytes of internal RAM and 1K of internal ROM that contains the system BIOS. The 8048 has 2 8-bit I/O ports. The first I/O port is for the cart bank switches 1 and 2, keyboard scan, and to enable the video display controller and external RAM. The second I/O port is to read the keyboard. And finally, the 8048 has an internal timer counter and an interrupt input. Below the 8048 is the Intel 8245. It is a custom IC developed by Intel in partnership with Magnavox. The chip displays all the system's graphics and generates the sounds. The G7000 outputs at a resolution of 256 by 192 pixels. The 8245 was able to store up to 4 8x8 single colour user-defined sprites. It has a 16 colour fixed palette, however sprites may only use 8 of these colours. It is also able to display 12 8x8 single colour characters, however they must be one of 64 shapes that is built into the ROM BIOS. These can be freely positioned like sprites, but can't overlap each other. Each character's colour must be set independently. And finally we have the Motorola MC M6 8A10P. This is the external RAM for the G7000, which contains 128 bytes of RAM. So as you can see, the G7000 main board is very dirty everywhere. First I use a brush to brush off all the old dirt, cleaning around the areas around the board and unclog all the dirt that's been built up over the years on the board. Some areas I needed to move some of the wires out of the way to get inside some tight spaces to remove and unclog the dirt. Once that is done, I then soak the board with IPA and then use a toothbrush to unclog any remaining dirt that sat on the board, and using the toothbrush to thoroughly clean the connectors such as the keyboard and cartridge port, and use a tweezer to go inside the cartridge connector to remove all the dirt and grime. I then use IPA and a cotton bud to remove the corrosion that's built up on the posts of the cartridge connector. And finally, using a cotton bud to remove the final bits of remaining dirt that's built up on the cartridge connector. The next part of the restoration is now to replace the old capacitors that have been on this board for almost 40 years. We're going to replace the capacitors with new high quality capacitors, very much like the ones that were used on the board originally. One by one we remove each capacitor. This process can take some time, but with the right tools you'll be able to remove all the capacitors in no time. Because of how thin the actual board is, heat does transfer quite quickly. Pads are extremely delicate, so you have to be very, very careful. Now, with the majority of capacitors now installed, we just have one final capacitor to install, which is a large 4700 microfarad capacitor. Now, this capacitor has 3 legs, so how do we know where to put positive and negative legs? Because our new capacitor only has 2 legs, well, we need to do some digging around. We use a multimeter to test each leg. So the leg surrounding all the metal is essentially ground. The leg with the trace is positive, and the middle is just a support. If we flip the board back over, we can see the signs positive and negative. This revision of the G7000 may be different to the board you have, but I hope it helps. We have to use a bigger soldering iron tip for this process because the ground plane will absorb all the heat if we use a smaller tip. The process to remove the capacitor takes some time, but we are able to remove it eventually. We then clean up all the remaining solder with some solder braid. And here is a comparison of the size of the original capacitor with the new one. So now it's time to install the new capacitor. So with the new capacitor now installed, let's test the old one. And measuring the capacitor with the TC1, we can see we're getting a higher capacitance. But this is normal, especially for the aged capacitor. So it's a perfect time to replace it. And the final thing to do on this board is replace the thermal paste on the voltage regulators and the heat sinks. We remove the old thermal paste using a cotton bud and IPA. We then apply new thermal paste to the heat sinks and the voltage regulators. And once screwed back on, we just give it a simple clean, removing the excess thermal paste that has spilled out. And that's it, everything has been replaced. The thermal paste on the regulators and the heat sinks, and the capacitors on the board. With the board now fully complete, let's move on to the metal shields which have corrosion around them. Both pieces have corrosion around them. The first thing I decided to do was use a Dremel to remove the corrosion from each piece, going around them until the corrosion was gone. While this worked, it left pieces looking rather odd, so I decided the next best option was to spray paint all the parts. So I wanted to just give you this bit of guidance before we go ahead and proceed with spray painting these 2 metal shields here. And whenever you're going to be spray painting anything really, always wear goggles, a mask, and do it in a well open ventilated area. So I'm doing it outside in a summer house, but with the doors wide open, so basically all the toxic from the actual spray paint goes out the door, it does. So let's go ahead and proceed with spray paint. So with the spray paint now on both metal parts, we're going to leave that to dry for a bit and now focus our attention on cleaning the shells for the G7000. First, we focus our attention on the bottom shell, which is very dirty. Before we can clean it, we first have to remove the screw mount, which is broken from the main shell. To remove it, we are going to use a screwdriver and hold the post with some pliers while trying to detach the screw from the post. With that successfully done, let's now focus on the next shell. And it's the same story, it is very dirty. We first have to remove the RF modulator away from the shell. There are two screws holding it down, which we have to remove. With the RF modulator now removed, we can now focus our attention on removing the clamps that hold the two shells together. There are 7 clamps in total that we need to remove. The process is quite difficult and requires pliers to loosen the clamps away from the posts. And with the clamps now removed, we can now separate the two shells. This process is quite difficult and requires a spludger to get under the shell to separate them. And as you can see, it is extremely dirty underneath. The next thing we need to do is remove the keyboard, which can be loosened using IPA. All the shells and the keyboard are extremely dirty. Grime and dirt built up over the years, so this is the perfect time to give them a well-deserved wash in the shower. And for the keyboard, I use IPA to clean away all that dirty grime that built up on both sides of the board, and even removing the corrosion. All the parts will be left to dry for around 24 hours. So I noticed that some areas around the board had exposed traces. So for this, I decided to protect the traces by applying some UV solder mask to protect them, and then placed it in the sun for it to dry for around 20 minutes. And with that done, we can now check on the metal shields that we spray painted earlier. Both are looking amazing. No more corrosion present, just a clean shield to now reinstall onto our main board. But let's first reinstall these 3 shields, which didn't require the spray paint treatment. Each of these shields need to be resoldered back to the main board. And with the first 2 shields now soldered back to the main board, we now need to clean away all that old flux and then reinstall the 3rd shield, which sits on the other side of the board. And with that done, we can now flip the board around. We can now reinstall the first part of the main shield. And finally, we reinstall the top part of the shield. Twisting the metal tabs which lock the shield in place. And I put a small note on the shield with information on when the recapping took place. And here are the clean and fully dried shells that are now looking absolutely fantastic. Plus the keyboard membranes is looking a lot more cleaner, especially with the corrosion now gone. The next thing we need to do is fix the screw post and the crack on the side of the shell. For this I will use a strong epoxy to fix the screw post and the crack. And for the crack I apply a thin layer of epoxy around the corner of the shell to essentially create a new coat to basically hold the crack together. And 24 hours later, the results are looking great, with the screw post securely back on and the crack on the side looking a little better. While not perfect, the plastic is no longer split and is held together nicely. And with that done, we can now move on to the next stage. So next we need to reinstall the keyboard. First we cut and stick a new piece of double-sided tape on the back of the keyboard. And then we reinstalled it onto the shell. With that done, next we reinstall the top shell. And reinstalled the 7 clamps one by one. With that now done, we can now reinstall the main board by first installing the keyboard ribbon cable to the main board. And then screwing down the 3 bolts around the board. So with that done, next we are going to install our new composite mod. We no longer need the RF modulator, but the modulator will come in handy as it will give us an idea where to install the 5 volts, the video and audio signals by opening it up. As you can see, it is clearly marked and will help us as we intend to use the original pin connector and its wires. And here is the composite mod board that we'll be using that was created by The Future Was 8-Bit. So let's get to work. We need to strip all the wires. We then tin each wire with solder and then one by one install each wire onto the composite mod board, following the instructions on the website. Once done, it should look very similar to this. Now some G7000s have 4 pins, while others like mine only have 3 pins. For the 3 pins, we'll connect the ground cable to a ground pad on the main board. We now need to install our composite cables to the mod board. Now we only need the video and 1 audio cable as the G7000's audio output is mono. We then strip the cables, tin them and install the audio, video and ground cables to the mod board. Now I don't want to cut the case, so I will install the mod board using double-sided tape onto the main shell and use additional tape on top to hold it together. We then install the pin connector to the main board and then solder the ground cable. We then route the composite cable under the RF modulator and then screw it down to the case. So let's test it before we put it all back together. And as you can see, the video signal is really sharp, but you may notice scrolling noise appearing on the image going up. This is down to the power supply I'm using, which isn't very good. Now buying a replacement or buying the original for the G7000 is near impossible. So I decided this would be a great time to give the G7000 another modern upgrade, replacing the original power port with micro USB. To perform the mod, we need a micro USB breakout board. These are readily available online and you can even get these in packs. We first need to remove the original port from the board. Now the G7000 has two voltage regulators which has a max input of 35 volts, but outputs at a fixed 5 volts. The reasons are unknown why there are two voltage regulators. A standard USB charger supplies a consistent 5 volts, which is plenty for the G7000. We need to remove the voltage regulators as we no longer need them. Also, we need to remove the filter caps and the large capacitor. So we first solder a wire from the output of the left side of where the original voltage regulator was to the end positive pad of where the original filter cap was. We then jump the output and input pads of where the original right voltage regulator was and jump them with a wire. Now here is the micro USB breakout board we'll be using. Now all we need to do is solder two wires on the solder points on the breakout board, one on the V bus and one on ground. To mount the breakout board to the main board, I'm going to apply some masking tape to the main board first. I then apply some super glue to the masking tape and then mount the breakout board to it. I leave this to dry for around 24 hours before proceeding with the next stage. Once dried, we can then solder the V bus and ground cables to the positive and negative points on the main board. And with that done, we can now one final time reassemble the G7000 once again. And finally, let's screw down the final 3 bolts. And here it is, the fully restored Phillips Videopac G7000. And it is looking a lot better than it did before. All that dirt and grime has now been removed and the system has received some modern improvements. So, let's play a game of space. Which plays fantastic. And here is a comparison of the footage before the USB mod was done and then after. And it looks absolutely amazing. So, I hope you've enjoyed this video, and until next time, bye for now.